Um, this is Alexis Nduwimana. We are dealing this week with classification of stellar spectra. I'm going to show you how to run the program. And if you cannot run the program, the CLIA lab, I want you to follow what we have on the screen, and you'll be able to collect the information and put it in your lab report for this week. So I'm going to do a tour of the lab, and I just want to pay attention and get the information. You can go back. I'm going to record the video, and please go back and see what we have. Okay. Okay, so we are going to use the CLIA lab, and I'm going to log in. Okay, so the first thing we are going to do, we are going to click on the run and do classification of spectra. And then we are going to select unknown spectrum in the program file. And we're going to start the first one. Okay, as you can see, this is the spectra. It has a continuum over here, and it has absorption lines out there. And this is the intensity trace way of presenting the spectra. There's another one that we are going to be asked to display as grayscale photo. The one we had was the intensity trace. Now let me show you how to look like. Again, we have the continuum, and we have the absorption spectrum. Okay, now we're going to go back and display as intensity trace, and we're going to try to get what are the absorption lines, get the intensity and the wavelength. For example, over here, if I click over here, it's going to give me the intensity. It's going to give me also the wavelength. I can get another one out here. Again, we have the wavelength and we have the intensity. And I can click on the continuum over here. See, we have the intensity and the wavelength. I can choose maybe another little bit higher. Okay, and I can see you can be able to have the intensity and the wavelength. The continuum is a little bit larger, and we have the absorption spectrum out here. Okay. Another thing I'm going to try to see is what kind of absorption line do we have? I'm going to need to go on File and select Spectral Line Table. I'm going to move it just on the side here. And then I'm going to try to see, focus on the absorption line. For example, you are given like this one. And here you see alpha delta that is responsible for this absorption line. And we have this, I think that's the lowest. You can click on this and be able to see which one. I need to select it properly, you know, which one we have. I can select this one. It's going to give me, let me select it properly, and be able to get that H gamma line. So we are going to be able to answer the question in the book based on what you just saw here. Now I'm going to close this and then be able to actually classify what kind of spectrum we have. So we have a kind of standard. I'm going to bring this one, and we are going to use the main sequence. I'm going to click OK and just move it on the side. Okay, as you can see, these are for high temperature to low temperature. If you want to lower, you can always go down. You go to A or B, B6, A1, A5, all the way to M5. As you can see in the spectra, you have the spectra standard, you have the spectra that we chose, and also have spectra standard. What I'm going to select, I'm going to select the difference. So which means it gives me the difference between the spectra standard and the spectra that I selected. And if the two were the same, I'd be able to see actually it's going to be coincide with this black line over here. this red lines, which is the difference, will be like a straight line at 0. So what I'm going to do, I'm going to scroll through up or down to see where it gives me 0. Sometimes you're not going to be exactly 0, so which means I'm going to make an approximation. If, for example, it's between M5 and M0, I can say maybe it's M3 or M2. So I'm going to do for many lines, for many spectra, and we are going to be asked to complete table 1 from the book. So I want you to pay attention on the differences, and they're going to determine which spectra we have. So I want you to pay attention for the first one. I'm going to go down and look where this line is going to be 0. So it's up to you now to select which one it is. I'm going to go up, up. I hope we're able to see which one is closer to a difference almost equal to 0. With this, I'm going to select different kind of spectra, and I want to pay attention at the same way we did. And I'm going to be quiet. Just I want you to follow, read the spectra, look where the difference is closer to 0, and choose and fill table number 1. So I'm going to start now going to the unknown spectrum and do next. Just I'll be pressing next, then going up and down in the main sequence standard. And I want you to pay attention and be able to answer the question. Go to do next. This will be number 3. Go to do next. 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 Okay. I'm going to do next. Go to next. 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 Okay, next. And if you understand all this, we are going to stop it here for the spectra because we can have enough at least 15. Now we are going to move to the next step, which is actually be able to get the spectrum and be able to classify it and be able to get the distance to the star. Okay, so I'm going to exit. Okay, now we're going to do run, and we're going to take some spectra. Okay, so we're going to open the DOM. Okay, we have a lot of stars out there, so we're going to be able to actually take some few stars over here. So let me just increase it. I'm going to take one large star. I'm going to center it. Then I'm going to change view. It's not exactly the way I want it. I'm going to make sure it's centered. Okay. I'm going to make sure it's really centered, and I'm going to take the reading. Okay. Okay, and actually I can easily stop it because the signal noise is more than 100. I can stop it. Okay, I wanted to read this the object we have. You can have the apparent magnitude, read all this information and record it in your lab manual. So we're going to save it. And this is 494, and we're going to record it. Okay. And then we're going to we're going to return, and we're going to select another one. So they want us actually to take a small one, so I'm going to move it maybe to one of those that are maybe smaller. Okay, I'm going to increase. Okay. I'm going to take one of the three. I'm going to change view, and I'm going to select one of those. Make sure it's fully centered on it, and then we're going to take the reading. Okay, start the reading. Of course, this one may need to take a little bit longer because we are going to need actually the signal to ratio up to 100. So I'm going to just wait a little bit more until we get 100 and be able to record it. We are using object number 39. as you can see, taking shape. Okay, now that it's more than 100, we can stop it, and we can read all this information. I want to record the apparent magnitude, rate ascension, the declination, and photon count is going to be recorded in the lab, and we're going to save it. So it's object 39. So it's going to be saved. This is the name of the file. Okay. Now we are going to try to classify all the spectra. Okay. Okay. Now the next step, we are going to try now to classify the spectra that we have done. So we're going to go to File, and we're going to do the set spectrum. We're going to start with the 494. Okay, the way we did it before. We do the difference, and we're going to go through to see which one it is. So I want to pay attention and tell me which one we have. So I'm going to go up. Okay, I'm going to do the same thing for the other one. So unknown spectra, save, and I'm going to do the 39. Okay, I'm going to go down to see which one it is. Pay attention on the difference. Okay, so that should be the whatever you need actually to be able to get whatever you need, and the other information we're going to get it with the hint that I'm going to give you through the question. In particular, how to calculate the distance to these stars and if they are in the Milky Way or not. Okay.